Okay, so now we're going to discuss the elongation with respect to protein synthesis. And so we're going to describe the elongation in prokaryotes as well as in eukaryotes. So basically, the elongation in bacteria is going to require that whole initiation complex that we've already discussed. So the initiation complex, remember, is going to be made up of the ribosome, so the complete ribosome. You have to have the messenger RNA there. You have to have the start codon and the anticodon pairing up with that tRNA for that first methionine. And bacterial, that's that formal methionine. And then you're going to, of course, require for elongation additional amino acyl tRNAs, activated tRNAs with their appropriate amino acid attached. And you're going to use elongation factors. So we have elongation factor TU, TS, and G. Now for elongation, you're going to basically have 3 steps that are going to get repeated over and over again. And so you're going to have, of course, the appropriate amino acyl tRNA with its bound amino acid in the GTP formed, and that is going to be carried out by the elongation factor TU. So the TU is actually going to bring in the GTP for this process. And so you have that first methionine shown here, and that's going to then allow your second methionine, your second amino acid to come in, shown here. So here's number 2. And so your first methionine is in position P. Your second one that comes in is in position A. And then you're going to have your elongation continue by having that GTP get hydrolyzed. So now you have TU release as a GTP plus an inorganic phosphate. Your elongation factor TS is going to help to recycle TU and is going to enable the transfer of GTP to TU to recycle that. And then your GTP-TU can associate with another activated tRNA with its amino acid. Now the ribosome is then going to move one codon towards the 3' end, and you're going to shift the anticodon from the A site to the P site. And so again, here you have your start codon, and then you have your second incoming amino acid 2. So here's your methionine 1, your second amino acid 2, and you're just simply going to shift. And so again, in this place, you have your start codon here. It got shifted to the exit. It has no amino acid associated with it, and this guy is going to leave. And then you have your second tRNA move from the A to the P site, and that has that second amino acid here, and you still have your first, so 1, 2. And then this hydrolyzes the GDP, and that again will be released and be recycled. Now eventually you're going to have the release of your initial start codon from the E site. You'll have another tRNA with its amino acid, with its TU GTP bind to the A site, and you'll continue to grow this chain. Now, elongation in eukaryotes is going to be similar to bacteria. Again, we have our eukaryote elongation factor, alpha. That's going to be similar to that TU, so that's the one that's bound with GTP that comes in with the transfer RNA, gets hydrolyzed and then released and recycled. Eukaryote initiation factor 1 beta gamma is going to be similar to that TS, and that's going to be able to recycle the elongation factor 1A by adding back that GTP. And then eukaryote elongation factor 2 is similar to elongation factor G, and that is going to move the codon from the A site to the P site using GTP as that energy source.